So in the previous lecture, what we have done, we have covered about, I think, the transfer. We have started the transfer matrix, right? The transfer matrix. And in this transfer matrix or transfer function, you can say, we also derived the transfer function from the state space equation, and that equation is given by that ys is equals to gs into us, and that gs is given in the term of, anyone can tell me, c into, please, si minus
C into
So
SI
minus
minus
A
A,
a
into
what's
inverse,
into
yes,
B
into b plus
plus
d if
B.
the d is
Right.
there. In the most of the cases, the d is absent, or if the d is there, then you have to find out the transfer function like this, right? So also we have done one or two numerical problem based on this, okay?
Yes, sir.
So that we can understand the transfer function, how the transfer function is going to drive. Okay. So today I am want to discuss about the, if your input vector, right? If your input vector u is, let's say, the r dimensional, right? R dimensional. R dimensional means we have u1, u2 up to the ur, right? And the output vector, let us consider the output vector, you have the y is, let's say, the m dimensional, right? M dimensional. So m dimensional means you have the y1, y2 up to the ym. Okay. So the transfer matrix, then the transfer matrix becomes, you know, the transfer matrix is defined in the order of m by r, right? Because m is the order of this y and r is the order of the u. Okay, so m by r transfer matrix is going to be defined for the transfer matrix, right? And this is given like the relationship between, given like this, you know, the y1, let's say y1 is there, y2 is there up to the ym, right? And the r ur matrix is given like u1, u2 up to the ur matrix, right? And the relationship containing the y and u is given in the terms of g11s, g12s, right, up to the g1rs, g21s, g22s up to the g2rs, and it is come to the gm1s, gm2s, right, up to the, you can say, gmrs. So this is the relationship between the y and r, where g, and how the g calculated we already have discussed, right? The I comma j th element of gij, right, gijs of gs is what is this, what is the gs, what is this? This is the transfer function, this is the MIMO system, yes or no? This is the MIMO system, multiple input multiple output. And what is the g1, g1, these are the transfer function relating to the output, relating to relating to the ith क्या, output, yes or no, and jth input, right? समझ में आया कि नहीं आया, yes or no? ith output and jth input को जो लिस्ट करेगा, that is given in the terms of like this one, okay? And how this gs is going to calculate? Again, the same formula you can adopt. Gs is equals to c into si minus a inverse into b plus d, right? Based on this formula you can find out the g. Okay, समझ में आ गया? Let's say you have to calculate y1 upon u5. So y, it is what, this is what, g15, right? So g15 you can calculate, yes or no? You can calculate. So this is the fundamental of the m by r matrix. Okay, now think about the another type of the equation, Wait a minute. Wait a minute. We already have covered this part, na? Okay. So, okay. Now, let's say we want to calculate the transfer function or the transfer matrix, right, of a closed loop system, of a closed loop system. So, how we can calculate the transfer matrix? Please see. Let's say we have the block diagram, the standard block diagram of any of the closed loop system is given like this. You know that this is a G naught S, right? And then this is the YS, this is the BS, right? And let's say this is the US is provided from here. The error is generated here, and based on this, the all the calculation will be done. So as you know that what you write what is the value of BS? BS is nothing but the HS into YS. Yes or no? Yes or no? And what is YS? Am I audible to all of you?
Yes, sir.
Yes, sir.
What is YS? YS is nothing but the G naught S into the
ES into G
ES.
naught S. Yes.
That's right. And hence you can write the YS. YS is equals to, you know, YS is equals to G naught S, right? G naught S into ES, and this ES is written in term of US
US minus BS.
minus of the BS. US minus of the BS, and this G naught S US, and you know the what is the value of BS? BS, है ना? So you directly write out the BS value, HS into BS or BS, you can say simply HS into YS. HS into YS. Yes or no? BS is equals to nothing but the HS into YS, or YS is written in the term of this, like, okay. So this is the YS, right? So now you can solve this equation, okay. 1 plus 1 plus G naught S, ठीक है, YS is equals to G naught S US. Am I right? This term should be taken this side and we have solved. Is it clear? Yes or no? Say yes or no.
Yes, sir.
Yes, sir.
So now YS become, what does YS become? 1 plus G naught S inverse into G naught S US, right? So this is the value of the YS, okay. Okay, and you know that the YS is nothing but the GS into US. We already have discussed the transfer matrix. YS is nothing but the GS into US. So you can see this is the GS. GS is the 1 plus G naught S inverse into the G naught S. In the term of this, we can calculate like this one. Is it clear? So in this way, we can calculate the transfer function of any closed loop system. Is it clear? Now, it is also it is not very tough to find out the transfer function of the closed loop system by this term, and you also know how the transfer function may be calculated. Okay, आपको पता है GS अपॉन 1 प्लस GSHS है ना, 1 अपॉन G नॉट, और इससे भी आप ऐसे कैलकुलेट कर सकते हैं, ठीक है. ओके, नो प्रॉब्लम. अब आप देखें कि प्रॉब्लम हमारे पास है एक, जो एक कंपनसेटर का प्रॉब्लम है, और इट इज वेरी वेरी इंपॉर्टेंट. और आपसे कहा जाएगा ये, लेट्स से आई आस्क्ड to determine the transfer function of this compensator. Okay, and also this this problem will be the the closed loop. Just first of all see the problem. Consider the system shown in figure, right? The problem is given like this one. This is the R1. See very carefully GC11. I hope all of you have aware of this circuit. Sorry. And another. Please see. This is the Y2, right? And this is the feedback for the Y2. Now this is the GC21 connected with this as a plus, and from here there is a one GC12, sorry, GC12, and it is connected with this as a plus. This is the U1 and this is the U2. Yes, Ajo. And yes, बोलो. क्या करना है? कर लो. So this is the one. Now you have to. This is the problem. This is the problem, and you have to find out the transfer matrix. Okay, we have to find the transfer matrix of this problem. So first of all, tell me this is which type of problem? Single input, single output, or multiple input, multiple output? Which type of problem? What do you think?
Multiple.
Multiple input,
Yeah.
multiple output. Right. MIMO system is this one, right? And this circuit has a specific name. You know, just I minimize the board. This is the you know the series compensator. This circuit is known as the series compensator, right? Series compensator. So we have the question is you have to calculate or determine the transfer matrix of the given series compensator such that closed loop transfer matrix is GS is equals to 1 upon S plus 1, 0, 0, 1 upon 5S plus 1. So this is the closed loop transfer matrix is given. Closed loop transfer matrix is given, and you have to calculate the transfer matrix of the overall the series compensator, right? So this is the problem. Now how you proceed to solve this problem? So before going to the detail of the solution of this problem, you have to understand how to solve such type of the uncoupled or coupled problem, right? So for this purpose, to solve the above given problem, above mentioned problem, we have to first we have to first analyze the transfer matrix, the transfer matrix of non-interaction system. Remember, non-interaction in MIMO. ये अगर हमें समझ में आ गया कि नॉन इंटरेक्शन एमआईएमओ सिस्टम में कैसे कैलकुलेट करते हैं किसी भी सिस्टम का ट्रांसफर मैट्रिक्स और ट्रांसफर फंक्शन, then you are able to find out the one of this is one of the easiest problem. उसे मत पे को प्लास्टिक गर्म करके ये खराब हो जाएगा. ठीक, ओके. So next you have to, so for this purpose let us consider transfer matrix GPS. लेट से हम कह रहे हैं किसी n बाई n प्लांट का या किसी मैट्रिक्स का, है ना, ये कोई ट्रांसफर मैट्रिक्स है किसी प्लांट का. लेट से लेट अस कंसीडर ट्रांसफर मैट्रिक्स जीपीएस ऑफ एनी प्लांट, और इसका कैरेक्टरिस्टिक कैसा है, n बाई n मैट्रिक्स, एंड फॉर दिस पर्पस वी हैव टू डिजाइन अ सीरीज कॉम्पनसेटर. हमें क्या करना है, वी हैव टू डिजाइन द सीरीज compensator GCS. We have to design this one also. Okay, and this GCS is also have the characteristic of n cross n matrix. Right? It means what it signifies. It signifies we have the n input and we have the n output. We have the n input and we have the n output, and both are uncoupled. Right? Now uncoupling कैसे हम समझेंगे और नॉन इंटरेक्टिंग कैसे समझेंगे. If non interacting or uncoupling between the input and output are there, between input and output is desired or there, right? आपको कैसे समझेंगे इसको, कैसे समझेंगे. इट मीन्स जो क्लोज लूप सिस्टम होगा, तो क्लोज्ड लूप का जो ट्रांसफर मैट्रिक्स होगा, दैट मस्ट बी डायगोनल. और आपको एक बात और पता होगा, नहीं पता है तो आगे लेटर वी विल डिस्कस इन द नेक्स्ट क्लास, diagonalization of the matrix. So in the diagonal matrix, you know, this is the diagonal matrix. It is given of the closed loop transfer matrix is given in the form of the diagonal matrix. Remember, and you know the diagonal matrix का ये जो वैल्यू है diagonal element that represent the eigen value of the system, right? तो अभी हम देखेंगे इस बात को. तो ये क्या है, कोई डायगोनल होना चाहिए, और डायगोनल होने के लिए डायगोनल कैसे करेंगे, डायगोनल नहीं है तो क्या करेंगे, वी विल डिस्कस लेटर. दिस इज डिस्कशन ऑफ सेपरेट डिस्कशन. सो वी हैव, इट मींस डायगोनल होना चाहिए कौन सा, क्लोज लूप ट्रांसफर फंक्शन. और क्लोज लूप ट्रांसफर फंक्शन जीएस डायगोनल, इट मींस इट हैज द कैरेक्टरिस्टिक लाइक दिस G11S 0 0 G22S 0 एंड अप टू द 0, इधर भी 0, यहाँ पे हो जाएगा बेटा GNNS, राइट. वेयर GS इज क्या है, GS इज द डायगोनल मैट्रिक्स. हेलो, डायगोनल मैट्रिक्स. यस, हु इज दिस सर, मैं, हाँ मैं क्लास में ना. GS इज द डायगोनल मैट्रिक्स, राइट, एंड provided HS is, you know, GS आपका दिया हुआ है क्लोज लूप का. व्हाट अबाउट HS? HS कैसा होता है, HS is the unity feedback system, or in the vector form how it can be represented. HS कैसे रिप्रेजेंट करेंगे, बोलो भाई, HS कैसे रिप्रेजेंट करेंगे, इन द फॉर्म ऑफ आइडेंटिकल मैट्रिक्स. यस और नो, अरे समझ में आ रहा है या नहीं आ रहा है? आइडेंटिटी मैट्रिक्स, or you
Yes,
can
sir.
say unity feedback. Unity feedback. For the closed loop system, we need GCHS. Yes or no? GS is given in the diagonal matrix, and the characteristic of this matrix is given like this. Okay, and how the how the transfer matrix is calculated. How the transfer matrix is calculated, you already know. We have already calculated for the closed loop system. What is the GS? How can we calculate it? 1 plus G naught S इनवर्स इंटू G naught S. अभी अभी देखा आपने. यस और नो? यस और नो? बोलता ही नहीं है सब.
Yes, sir.
Yes, sir.
where G naught S is nothing but the GPS into the GCS. इसका मतलब क्या है? What is G naught S? मैंने अभी अभी आपको बताया. This is the GS, simply G naught S, जो in the feedback system. But in the real time problem, G naught S is divided into two terms. First is the plant, and second is the controller. Yes or no? Yes or no?
Yes, sir. Yes,
So
sir.
this G naught is the multiplication of controller and the GPS. So this is given like this. Is it clear? Is
Yes,
it
sir.
clear? Okay. So now we can write it as this equation may be written as G naught S is equals to 1 plus G naught S into GS into GS. Yes or no? So when you solve this equation, you can calculate the value of G naught S from this equation. So G naught S you can calculate by solving this equation. You can write this GS into 1 minus GS inverse. GS into 1 minus GS inverse. ठीक है? तो दिस इज द सिनारियो. G naught S ऐसे कैलकुलेट हो जाएगा आपका. अब हम लोग देखते हैं ये है क्या. ये है क्या. और आपको अब मैंने बता दिया कि G naught S जो है, G naught S should also be the diagonal matrix. ये भी देखते हैं कैसे. सो अभी आपने कैलकुलेट किया साहब कि G naught is nothing. G naught is equals to G into 1 minus G inverse. ये इस इक्वेशन से आप डायरेक्टली कह रहे हो. एंड G is given for the above problem. G is given for the above problem like this one. What is the G? You can see here. G is given. Closed loop transfer G is given. 1 by S plus 1, 0, 0, 1 by 5S plus 1, right? So based on this GS, see the problem. Yes, G, sorry. Wait a minute. I don't know why it misbehave. Okay. So G is, it is visible, na? Is it visible?
Yes,
Yes.
sir.
Okay.
Yes.
So G is given, 1 by S plus 1, 0, 0, 1 by 5S plus 1. G is given. So you can calculate this value. Yes or no? 1 minus G inverse you can calculate. It will come S plus 1 upon S 0, 0, 5 S plus 1 upon 5S, right? And when you multiply it by the G 1 minus G inverse, it will come. I'm writing directly 1 by S, if I'm not wrong, 0, 0, 1 by 5S, right? So this is the G naught. This is the G naught. Okay. And you already told, sir, Y is equals to nothing but the GS into US. YS is nothing but the GS into US. And what is the YS? YS is nothing but the two output is there. First is Y1S, second is the Y2S. Right? And what is GS? GS is given already. GS is given अब जरा जो सिस्टम का देखिए, सिस्टम का यूएस में कैसे है ये, हाउ इट इज कोरिलेटेड। मैं पिक्चर पे जाता हूं, मैं फिगर पे देखूं जरा, अगर आप फिगर पे देखें तो यस, y1s, y1s एज इक्वल्स टू क्या लिखेंगे, 1/2s प्लस 1 us, y1s एज इक्वल्स टू नथिंग बट 1/2s प्लस 1 u1s। ठीक है कि नहीं, यस और नो? अरे y1s is equals to this into u1s, am I right?
Yes.
y2s,
Yes.
y2s is equals to क्या होगा, y2, what is y2s? y2s is nothing but the 1 into us, first 1 into us u1s plus 1 upon s
S into U2.
plus 1 u2s, yes or no? So you can
Yes, sir.
write in the matrix form now, it is 0 plus, you can also write u2s, right? So now you can, I don't know why it may have okay, okay. So you can write here 1 upon 2s plus 1, 0, 1, 1 upon s plus 1, u1s and u2s. If I'm not wrong, you can write it like this. Yes or no? This is you have
Yes.
written from figure. Okay, and also, and also, and also, अब अगर दोबारा फिगर को देखेंगे आप, तो आप देखोगे क्या, ये जो दोबारा अगर आप पिक्चर को देखिए, let us consider once again the picture, please see what is u1 and what is u2, यही तो आपको निकालना है, यही तो आपको मैट्रिक्स निकालना है, gc11 gc12 gc21 gc22, you have to calculate this one. तो what is u1, u1 is nothing, ध्यान से देखिएगा जरा, अगर आप इसको हम u लिखें, जो आपका u1 है वो है क्या, आप इसको लिख सकते हैं कि सर gc11 इंटू क्या, ये जो आपका वैल्यू है r1 माइनस y1s, या सुनो, फिर से बोल रहा हूं मैं, ध्यान सुनो, ये जो आपका कोरिलेशन है y1 और u1 और u2 को हम कैसे लिख सकते हैं इन द टर्म ऑफ दिस r1 और r2 और y1 y2 के टर्म में, तो इसको मैं ऐसे लिखेंगे, ध्यान से देखिए जरा, ये बेसिकली एक एरर है, यहां पर इसको हम E1 एरर कहते हैं, इसको एरर कहते हैं, है ना, इस एरर को हम इसको इस टर्म में लिख सकते हैं क्या, आप जरा देखिएगा, u1s u2s इक्वल टू जी, यहां पर हम लिखते हैं r1s माइनस y1s r2s माइनस y2s, दिस बिकम द एरर, समझ में आ रहा है, ये जो मैंने लिखा था यहां पर ऊपर से जो आ रहा था, दिस इज द एरर r1s y1s, इज इट क्लियर? और यहां पर क्या है आपका gc11,
Yes.
सो दिस इज द gc11s gc12s gc21s and gc22s. If I'm not wrong, you can write like this also. Is it okay? Is it okay? आप दोबारा इसको जरा प्रैक्टिस करके आप इसको देखिएगा, कैन आई राइट और रॉन्ग, नो नॉट राइट नाउ,
सर राइट है।
ओके, अब इस वैल्यू को u1 u2s की वैल्यू आपको पता हो गया, जस्ट पुट हियर, just put here, so you can write now y1s y2s equal to 1 upon 2s plus 1, 0, 1, 1 upon s plus 1, gc11s gc12s gc21s gc22s into r1s minus y1s r2s minus y2s. So this is the equation. समझ में आ गया बात? अब ये अगर इसी को मल्टीप्लाई कर दिया जाए, व्हाट इज दिस, ys इज इक्वल्स टू g नॉट s इंटू यूएस, इनपुट, इनपुट ही तो है ये, बात समझ में आ रहा है, यस और नो? ys is equals to nothing but the gs g naught s into us, तो ये जो चीज है, अब आप इसका मतलब ये हुआ, इट मींस कि g naught s G naught S is equals to आपने निकाल रखा है. What is the value of G naught S? G naught S you have already calculated. Please see. This is the G naught S. So this G naught S is equals to 1 upon S 0 0 1 upon 5S, and also this is given 1 by 2S plus 1 0 0 1 by S plus 1 into GC11 S, GC12S, GC21S and GC22S. GC22S.
तो 1 आएगा नीचे.
ओके, GC21S ठीक तो है. कहां पर?
इसके 1/2s plus 1 के नीचे.
1/2s plus 1 के नीचे 1 आएगा. ओके ओके, यस यस, यू आर राइट, 1 आएगा. यस. Now just you can solve, just you can take the inverse, है ना, inverse ले लीजिए. And now there is no problem in order to solve the GC11 value. GC11S, GC12S, GC21S, GC22S is equal to the 1 upon 2S plus 1 0 1 1 upon S plus 1 and the inverse of this. Sorry, this is the inverse. ये इधर जाएगा ना. Yes, this inverse into 1 by 0 0 1 by 5s. Solve कर लो. Solve करने पे you can see I'm at the result 2s plus 1 upon s 0 minus s plus 1 2s plus 1 upon s है, और this is the s plus 1 upon 5s. तो अब जरा देखो, ये जो रिप्रेजेंट कर रहा है GC11 या GC12, GC21, GC22 है क्या? तो अगर हम GC11 की बात करें, GC11, if just consider the one component GC11s, so it is nothing but the 2s plus 1 upon s, and it is nothing 2 upon 1 plus s. Yes or no? Yes or no? And what is the characteristic of this compensator? What is the characteristic of this controller? This controller is nothing but the PI controller, if I am not wrong. Proportional plus integral. 1 upon s is integral. Yes or no?
Yes sir.
Yes.
It means the proportional PI controller is used in order to compensate, in order to control the system here. और ये क्या है आपका? This is the PID. This is the PID controller, right? This is the PID component. Again, this is the PI. Again, this is the PI. Okay. So in this way, you are able to find out the the GCS or the compensating value, compensating matrix, transfer matrix of the compensator of the uncoupled system or the coupled system, right? I think you understand. So here I am just stop the